Hello and welcome everybody to this Unreal Engine tutorial. My name is Classy Crustaceo with Crustaceous Studios, and today we're going to take a look at taking a 2D sprite and creating a free moving camera, much like a third-person camera, or in older PS1 games where you could be able to rotate the camera around a 2D sprite in a 3D level. Most notably, this effect has most recently been created with Star Ocean. And we're going to take a look at how we can be able to do this inside of Unreal Engine 5.7. So we're going to do a few things here. We're going to take a look at importing and setting up your 2D sprite using paper ZD, and then how we're going to get the sprite to face the camera, and then to finish it off by adding a shadow that will match our animations. So let's go ahead and dive on in. Before you get started, if you find this tutorial helpful, please give it a like and subscribe to the channel. It helps us in the algorithm reach more people that are looking for help with Unreal, and then you can get notified whenever any new videos come on out. Make sure to check out the description down below for a link to all of the assets that we're going to be using for this project, as well as some free resources that we've developed that'll help you organize your projects as you develop your game. So here we are in Unreal. There's a couple things that we're going to need to do to get started. First thing we're going to need to do is make sure that we have the Paper ZD asset installed to Unreal Engine. You can get that over on Fab. It is a free plugin. It is an amazing tool for anything that is sprite-based and 2D type of games. So make sure that you grab on that. So once we have it installed to the engine, we're going to need to enable it. So come to Edit Plugins, type in Paper ZD, hit the check mark, and it's going to tell us that we need to restart the engine in order to be able to use it. So once we do that, we'll be good to go. Okay, so once the engine is restarted, the next thing we need to do is grab our asset. So we'll head on over to itch.io, go ahead and type in small 8-direction characters, and you'll come across this asset pack that is under the Creative Commons Attribution 4 license. It is 3 characters that are 8-directional. It is great for 2D games and what we're going to be using this for. There are a few things about it that aren't ideal, but for what we're going to do, this is going to be great. This Creative Commons license allows you to be able to redistribute, use it in your games, recolor, do whatever you want to it, and redistribute this. So let's go ahead and download that. So once we have it downloaded, let's go ahead and bring up our content drawer. I'm going to create a new folder and call it Sprites. And this is where we're going to bring in our new assets. So go ahead and bring that in, drop it in. First thing that we're going to do once we have it in here is we're going to come up here to Sprite Actions, say Apply 2D Texture Settings. Then we're going to come up again, say Sprite Actions, and say Extract Sprites. Once we're in this mode, you can see Unreal tries to be able to see all of the different sprites that are on this sheet. This is typically a bad approach because it doesn't really know how to be able to distinguish everything apart. If your sprites aren't lined up correctly, it can create some really weird settings and really weird mismatch when you're trying to create things like Flipbooks. So what we're going to do is we are going to come over to Sprite Extract Mode. We're going to set this to Grid. So the first thing that's going to do is it's going to take this all as one entire cell, so we need to split this up. As you can see, we have our cell width and our cell height as 128 and 288 because that is the overall pixel resolution of the entire sprite sheet, but we want to break this up down further. If you count each row and each column, you can be able to divide the number here by what we have here. So we have 8 that's across. So if we just come in here and do divide by 8, you can see we get 16 and it separates everything nicely. And then here it goes up by 12, so the rows are 12. So we could divide by 12. And we can now see everything is perfectly broken up in, but it's not quite perfect yet, because if you come in here, you can kind of see how things are floating a little bit. So if we were to bring this into the engine, our character would be floating up a bit, and instead of trying to move the sprite around in our blueprint, we're just going to make some adjustments here. So the first thing we're going to do is we're going to come down to the spacing. We're going to mark this as 2. And it's going to look like it messed everything up and everything's out of place, but that's okay. What we're going to do is then for the cell height, we're going to come in here and we're going to subtract 2 from the top and bring it down to 22. And you can see how everything lines up just perfectly at the bottom. So now everything is looking really nice, and the bottom of our sprites are going to be at the bottom. A little thing to keep in mind is whatever you decide to adjust these. So for instance, if I take the spacing by 2 on the x-axis, and then I come here and subtract it by 2, it's going to recenter everything. So the same thing is true if this was 3, and we'll just subtract this by 1 because that'll equal 3. It ends up recentering everything again. So a nice little rule of thumb is that whatever you end up placing into your spacing, subtract that number from your width if it's x, or your height if it's y. But we're going to go ahead and set this back to the way that it was before and bring this back up to 16 so that we're good. Once you have everything all separated and looking nice, we're going to go ahead and say extract. And it's going to do its thing. Now I'm just going to go ahead and dock this down to the bottom so it's a little bit easier to look at and manage. So as you can see, we now have all of our sprites here that are completely separated. So the next thing that we want to be able to do is be able to create flipbooks. So I'm actually going to create a couple more folders here. And I'm just going to name it this guy red. So actually I'm going to take all of red here and place them into his folder just so it's separated so it's a little bit easier to see. And then in here, I'm going to create another folder, and I'm going to call this Flipbooks. So what we want to do now is we're going to find every single direction in the series of animations or sprites that are facing that direction and turn them into flipbooks. And the first thing we're going to start with are going to be the idle animations. So we can see here, here's all the different idle animations in all their different directions. Now I'm still going to create a flipbook even though it's going to be 1 just for posterity, just to make sure that it's easier to be able to identify. So maybe in the future I want to be able to add some new idle animation frames to this. So I'll have the flipbook that's set up and all I have to do is drag and drop versus putting in just the base here. So we'll just say right click, we'll say flipbook. I'm going to label this FB underscore red underscore idle underscore U for up. And then I'm just going to drop that into here. Now I'm going to go ahead and speed this up while I do the rest. So I've gone ahead and finished the idle animation flipbooks here and have truncated the direction that they're facing. So UR is upright, DR is down right, DL is down left, UL is up left, and so on and so forth. Next, what we're going to do is we're going to create the flipbook for the actual walking animations. Now this is going to be a little bit different. So a nice thing that you can be able to do with Unreal is that if you take all of the animations of the upward, so we want to grab this one where it looks like they're stepping left. We're going to grab the same one that we used for the idle, and then we're going to grab this one that looks like it was used for the right step forward. And then we're going to right click and we're going to say flipbook, and that's going to combine all 3 of those into one singular flipbook animation with all 3 frames. So again, we're going to name that. So it's going to be FB for flipbook, red underscore, I'm going to label this one walk, and then U for up. So we're going to do the same thing that we did for all of the idle animations, but we're going to do that with the walking ones. Okay, now that we have all of the walking animations, we just make sure that we have them all. We have our down, down left, down right, our left, our right, our up, up left, and up right. So now what we're going to do is we're going to go ahead and open up our first one here. Now as you can see, it's playing this animation and it's moving pretty quickly, which is a little bit faster than what we want. So I've found 5 is typically good for these animations. This looks a little bit better. But as you can see here, this looks kind of awkward. Because what is happening here, if I pause this, we can go frame by frame. We're starting off with 1 step. We're going to our neutral position, which is our idle. and then we're going to our other step, and then it loops back around, which immediately puts us at that other step. So if we wanted to, we could try playing it without, for instance. Let's remove this one here. We could just play these two, and that kind of looks okay, but I prefer to have a neutral spot because it looks more like you're kind of bouncing up and down like you would when you normally walk. So the way to be able to do that, to be able to duplicate these frames, it's quite simple. Right here is this middle frame where that duplication happens. So we just right click here, say duplicate, and then it's going to create the two frames right next to each other. So we don't necessarily want that because now we have a long set and it's still looping around. So what we do here is we just grab this here and then we just slide it all the way to the end. And you can see we go up, start with our step, up to neutral, next step, back up to neutral, and then it loops back around. And it gives us a nice clean looping animation that looks really nice. So once we're done with that, go ahead and save it. And then we're going to do the same thing to all of our other walking animations. Now, for our idols, we don't necessarily need to do that, but just for consistency's sake, it's good to be able to set them also at 5 frames a second. Some of the sprites that you may find or even create yourself will have very specific frames per second to be able to put them as, so you want to go by that, but for the purposes of this tutorial, 5 frames a second is fine for all of them. One thing that you can do is that you can select multiple of these at the same time, and if you right click here and go down to Asset Actions, Edit Selection and Property Matrix, once again make sure these are all selected, hit the sprite drop down, you can actually set the frame rate for every single one of these, so we can set this to 5, say save, and then we can see each and every one of these has 5 for its designated frames per second. Alright, so the next thing here I'm going to do is I'm going to come back up to our content, come into characters, I'm going to right click here and I'm going to say new blueprint class. So the nice thing about PaperZD is that PaperZD creates a whole bunch of new blueprint parents that we can be able to work with. So I'm going to go ahead and type in here and say PaperZD. And as you can see here, there's a PaperZD character, which inherits from the paper character, which inherits from the character class, which is what this class is right up here, which inherits from a pawn, and an actor, and an object, and so on and so forth. So we're going to go ahead and we're going to select that. I'm going to call this CBP underscore player. Now the reason I do CBP is that stands for character blueprint. I prefer to make this distinction. Other people will just use BP. Whatever your naming convention works best for you, but it's just important that your naming convention is consistent and easily searchable. Again, I use CBP, so if I want to be able to distinguish my character blueprints from my other blueprints, I can be able to do so. So for instance, if I just do BP underscore, it's going to show me all of my blueprints here. Then it makes it hard, so if I have a lot of blueprints, it's going to be hard to sort through them. But if I just do CBP, then it automatically finds the blueprint that I'm looking for. So again, characters. We're going to open this up. So this looks very, very, very similar to what a character blueprint looks like. There's just a couple extra added things that are in here that don't normally come with a character. As you can see, we start with a sprite, which is just a flipbook component, and then we have this animation component. So for the time being, I'm going to go ahead and place this sprite component in. I'm just going to grab a random flipbook. Let's go ahead and grab the idle down. And as you can see, it is incredibly tiny and incredibly small right here. So we want to be able to kind of fix that. So how we can do that is we can do a couple of things. We can either scale everything up. So let's do 10. That looks kind of good. But one of the other issues that you can see here is that we have this setting right here. And what this is you can see how the center of it is not really at the base. So we want to be able to change that. So it would make a lot more sense if the widget was down here and the bottom is where our character would actually be able to move. So how we're going to go about doing that is, I'm just going to rearrange this here. I'm going to come back to my sprites. I'm going to select all of them, come to Asset Actions, Edit Selection in Property Matrix, select all of them again, come down here to Sprite, and under here where it says Pivot Mode, we're going to set this from Center Center to Bottom Center. I'm going to go ahead and say Save. I'm going to come back here, and we can see everything has moved on up, and our pivot point is now at the bottom of our sprites. So let's go ahead and just drag this all the way down. Now I am going to undo our grid snapping here so we can move this up just a tiny bit so that way it lines up nicely and we don't have any clipping happening, and then I'll turn that back on. And we have the beginning of our character. The other thing I'm going to do here is I'm just going to rotate it 90 degrees so that way this arrow is facing forward. This is the special arrow component that comes with this blueprint class. It will not show up and there are no details over here. So in order to be able to have another arrow, we're going to just go ahead and come here and say arrow. We're just going to add our own. So that way we can have a little bit more control. And then for now, I'm going to turn off hidden in game. Okay, so that's pretty good. There's a couple other things that we can do here. Right now we're scaling up our sprite, which it's not necessarily bad. It is not great either. Ideally what we'd want to do is we'd want to tell Unreal to adjust how it views each pixel, because right now we're doing a scale versus being able to draw. This could also create some scaling issues in the future if we're trying to use different asset packs or anything like that. So how we're going to fix this is we're going to come over here. We're going to select all of our sprites again, not our flipbooks, but our sprites. We're going to right click, Asset Actions. We're going to do our bulk property matrix one more time. We'll select all of them here. We'll come down to Sprite Render, or sorry, Sprite, and come on down here to where it's pixels per unit. Now, this is where it's a little interesting, because if I were to come here and say, oh, well, we scaled up by 10, let's scale it by 10 and put that here, we're actually going to see everything gets smaller. So what we want to do instead of scaling it up by 10 is we want to divide this by 10, and that's going to give us 0.1. The rule of thumb is whatever you decide to scale up your sprite to, because see now it's giant, that's going to be what you divide everything by. So now it looks exactly the same, but it's going to render a little bit easier, be less intensive, as well as also make sure that if we bring in any other sprites or use this as a parent class, then we don't have any weird scaling issues, because we might bring something in that might be of a different, and then we have code that pertains to the scaling, and that can cause some really major issues. So by changing it here on the original sprite level, we can be able to make sure that all of our code moving forward scales the way that we want it to scale. All right, so right now we haven't done too much. So if I come here and I say play, we're going to see that we still have our third person template here character. So we want to make some additional changes. So first thing I'm going to do is I'm going to come over to our project settings. Go ahead and dock this up here. We're going to come to maps and modes. We're going to take a look at what our third person default mode is. We're going to hit this selected game mode, drop down here, and this is going to give us all of the parameters for our third person character. So for now, let's go ahead and drop this down. We're going to say CBP, player character. So now, once we start our game, that's the pawn that we're going to do. But we haven't set up a camera or any controls. So if I hit play right now, it's going to look a little weird. We can't be able to do anything. We don't even see our player because we're possessing something that doesn't have a whole lot to it. So let's go ahead and fix that. So under our capsule collider, let's bring in a spring arm. Awesome, we're going to do that. And then under our spring arm, let's go ahead and bring in a camera. And now we have our camera and spring arm. So let's go ahead and take a look. We should automatically possess. Look, and we do, but we don't have any controls right now. And that's okay, because we're going to add that functionality here in just a second. But I think this is a little close. I like to, where's my spring arm? There it is. I'm going to increase this to 500 for right now. And see how that feels. That feels a little bit better. Okay, so let's go ahead and build some functionality into our player controller so that way we can at least start moving around. And we haven't gotten to how we're going to face the camera, how we're going to rotate things yet. This is just kind of all the very basic setups. So let's go ahead and just knock this out real quickly. Okay, so first things first, I'm going to create a function. I'm going to call it aim. And I'm going to give this 2 inputs. This is going to be floats. So this first one is going to be x. Call this a float. We're going to create another one. This one's going to be y. More specifically, we'll call this the x axis. And we'll call this the y axis because this is going to be what our camera, our mouse input is going to be. So we're going to add controller yaw input. And our x value is going to come into here. Then we're going to add controller pitch input. And that's going to take our y value. Okay, so if we go ahead and play this, we're still not going to have any type of movement here. And that's because we haven't had things hooked up yet. So let's go ahead and do that. So we're going to come over here. We're going to type in IA underscore. We're going to look at mouse look, because this has been set up already in our third person template. So we're going to drag aim out. Then we're going to split this here. We're going to hook our x up to our x, our y up to our y. File save. We're going to give that a test. Now something tells me it still might not work. Yep. That makes sense. It might help if we plug it in. Okay, let's test it now. Alright, so yeah, so we have everything set on up. A few things to be able to take a look at here first is we want to make sure that we are using the controller rotation yaw on here. Our spring arm is inheriting our yaw. Our camera is not doing anything. Our character movement is not doing anything. Another thing to look at here is at the control. We want to have the use desired rotation turned off here. Want to make sure our use rotation yaw is on. Same thing come to our spring arm. Make sure use pawn control rotation is on as well. And that'll give us our ability to rotate. See, and we can see how it is always facing the camera. Now, if we come here and we turn that off, we should be able to rotate. Yeah, see how we rotate completely around. But we're going to leave it on for right now. And we're going to work on our movement. So we're going to come over here. We're going to create a new function. I'm going to call it move. I'm also going to give it 2 inputs. We'll have our x-axis again, and our y-axis here. Now, what we are going to do here this time is I'm going to come out here, I'm going to say sequence, just because I think it looks just a little bit nicer. So we're going to first get the control rotation. We're going to want to split this here. Then we're going to get our right vector. And then we're going to want to split this as well. We're going to connect our roll and connect our yaw. Then from here, we're going to add movement input. We're going to hook this up to there, and we're going to want to hook up our x-axis here. And if we come out and we look at our event graph and we go IA underscore move, we also split this struct. We drag move out. We've only hooked up one axis, but we want to be able to test it here. So what we did, this should let us move side to side. Yeah, so we can't go forward and back, but we can go side to side for right now, which is good. So let's go ahead and jump back in. And then now we're going to do the same thing, but instead of a right vector, we're going to grab our forward vector. So get forward vector. We're going to split. And this time we're only just going to hook up our yaw. Subtract that in there. We're going to hook that pin up there. Bring our y-axis down. I like doing it this way just because it's a little bit cleaner to be able to see what's going on. And then make sure that our y is hooked up here, and we should have control of our character now. Yep, so now we can go forward, we can go back, we can rotate the camera, and we can move our character around. So the next thing that we're going to need to do is we're going to need to get our camera to freely rotate around the character, which is going to come back to here. I believe it was here. We do yaw. Nope, we don't want to do that. We want to do our spring arm. No, that was right. We're going to uncheck that. And now we can do that. And as you can see now, when we turn and face our way, and our arrow faces it. So the big problem right now is that if we turn our camera, you can see when we use a 2D sprite, we get to this point where it disappears, and it's not always facing us. So how can we be able to do that? So let's go ahead and take a look at these next steps. So let's go ahead and take a look at getting our animations down, and then we can look at how we can get the character to face the camera. Alright, so now what I'm going to do, I'm going to come back over here to my characters. I'm going to right click, I'm going to come down to Paper ZD, and I'm going to find AnimSource. Now I haven't found a good naming convention for this, so I just do AnimSource, and then I'm going to say underscore red. And the reason I do that, you'll see here in a second. So we'll go ahead and open this up, and you can see that there is nothing here. So what this is going to do, this is going to allow us to be able to do all of our different angles based off of those flipbooks that we created. So first things first, we're going to come over here. We're going to say add new animation sequence. Now here I'm going to name this AS for animation sequence. I'm going to do underscore. I'm going to say idle. And then what we want to do next is come over and hit this multi-directional sequence. And this will give us this pattern on the side here, this grid. And what this grid is for is that this is going to determine exactly what flipbook we want to play based off of inputs. So we have 0, 1, 1, 0, 0, -1, and -1, 0. Up here where it says in, this is going to be how many different directions we have. So 4 right now would be if you only have a 4-directional movement, but we have 8, so we're going to come up here and say 8. So this here, we can be able to see if we wanted to do 10, we could do 10. If we wanted to do 12, we could do 12. There is a limit, but for the purposes of this video, we have 8 directions, so we're just going to go ahead and do 8. This angle here is if we're going to be doing something like isometrics, so we only have the angles. So for instance, we did 4 and we only wanted to do our catty corner angles, we could say 45 degrees, and then we have that, or in this case -45 if we wanted that to be our front. But we're going to stick with 0, come here to 8. Now this next step is relatively easy. There's a couple different ways we can do this. We're going to do it one way, and then later in the video I'll show you how we can do it another way. So the first thing we're going to do is we're going to make sure we're on this first section here. Come over here, and I'm going to look for idle U. So we have red, idle U. And we're all the way zoomed in. That's okay. So now we have that set up. So now we're just going to come around. We're going to get all of these different areas and make it look according to the direction here. Okay, now that we have all the directions, we can see all of our different 8 directions give us the correct side. We can preview if you hold down Shift, and we can roll through these. We can see we have a pretty good setup here. So now we're going to do the same for our walking animation. Do anim sequence as underscore walk. Multi-directional sequence, bring this to 8, and then we're going to fill in all of these with our walking. Okay, same thing, we can see we have all of our different angles. We hold down shift, we can rotate through all of them. So now we have all of our directions that is moving in the correct way. So if we're looking at this, this would be -1, 1, or at the most -7, 7. We can see we're moving to up and to the left. Same thing if we're +7, 7, up and to the right. If we're at 1, 0, we're moving all the way to the right, -1, 0, so on and so forth. So now we have our walking animations all set up based off of our 8 directions. So we're going to go ahead and save that. I'm going to close it for now. And the next thing we're going to do is we're going to create our animation blueprint. So we're going to right click, come down to Paper ZD, and we're going to see this Paper ZD Anim BP. So we're going to base it off of our AnimSource red. And we're going to label this ABP_red. And the reason we're going to name it the same and not anything extra special is because when you open it up, it's going to look very, very, very similar to a regular animation blueprint. So the only difference is that we have this result with ZD here. So now the next step, I'm going to come over here and look at this animation component. And I'm going to come down here where we look at our anim instant class. Now that we have our anim BP, let's go ahead and put in this here. We have our ABP red. And right now we're not going to see anything, but if I come in here and we drag off and we put our walk AS in, and we drop that, we can then look at this and say play. And if we go ahead and hit play, we can see our character is now walking. But we don't have any of the directional input, but right now that's okay. We're going to set up our basic functionality so that way we can walk when we're moving and stand still when we aren't. So just like you would a normal animation blueprint, we're going to create a state machine. Call this locomotion. Go ahead and connect this up. I'm going to drag off here, create an animation state. Go ahead and call this idle. Drag off here, create another animation state. Call this walk. We're going to open this up just like we did at the top level. I'm going to say AS idle. Commit that. Take a step up, open up walk. Say AS walk. Okay, so now we need to work on our transitions between these two. So go ahead and open that up. And what we want to do is we want to say get owning actor. We're going to change this in just a second here. We're going to get the velocity. Then we're going to get the length. And then we're just going to check to see if it's greater than 0. If it's greater than 0, then that means we want to transition to our walking animations. If it's not greater than 0, then we're going to stay. If we test this out, we can see, look, we're staying still. And then if we walk forward, we start our walking animation. So that's good. But right now, if we stop, we're not going to transition back. So let's go ahead and copy all of this over for right now. And we're going to drag from here back to idle. Bring that in. And instead, I'm just going to say if we are equal to 0, then we're going to transition back. So we're standing still. We move forward. We stop. And we are idle again. Okay, so we have the bare basics there. But what we don't have is the change in direction. but that's okay. That's going to be our next step. First, I want to make just a slight change to our setup here. I know that we just did this, but this was great for testing, and now we're going to make this a little bit more efficient. We're going to come over here to our event graph on our Anim blueprint, and I'm going to say get owning actor, and I'm going to cast this to our player CBP. So we're going to say cast to CBP, and this is where having this naming convention really comes in handy, because that way now I know I'm only looking at my character blueprints, where if I tried to cast to here, I'd have to try and sort through all of these. So we're going to say CBP. And then we are going to promote this to a variable. And I'm just going to call this CBP player, because that makes it very clear what it is. Now this is nice. On init basically means before this does anything else, when this is initially initialized, it's going to run this code. So we now have the CBP player code. So let's go ahead and come back here. Just going to delete this, and I'm going to bring in my CBP player. And then same thing on this side, bring in my CBP player. Test it, make sure everything still works. Yep, everything looks great. Awesome. All right. So now we're going to come back up to our anim graph here. Okay, now we're going to build in the logic for choosing what animation, what direction we're going to be looking at. So we're going to look at get directionality. Let's type this in direction. Set directionality, I apologize. We're going to plug that in here, plug this in here. And just to show what this is going to do, I'm going to split this struct. And I'm just going to set this to, I'm going to set this to 1 on the X. And when we play it, you can see we're looking to our left. So by doing this, we're going to be able to see what direction we're moving in. So we want to be able to drive these values. I'm going to show you how to do that first just with our input, but we're going to change it so that it's based off of our angle a little bit later. So what we want to do is we're going to come back over to our player BP, our CBP player. And what I'm going to do is I'm going to open up our move, and then I am going to promote this to a variable, and I'm going to call it our, again, our x-axis, because I'm original like that. Do some rearranging. We'll promote this to a variable as well, and we'll call this our y-axis. Drop that in there. Some rearranging so things look a little bit prettier. Then we're going to come back over to our animation blueprint. Since we have our player reference, we're going to go ahead and drop this in right here. We're going to grab our x-axis. We're going to plug this into our x. Then we're going to grab our y-axis. Set y-axis. We're going to plug this into our y. We're going to say compile. We're going to say save. We're going to hit play. And then you can see when we go up, we move this way. When we go down, we're facing the direction. Now, right now, if I move to the right, you can see how the sprite looks like we're moving to the right for a second. Same with the left. But right now, because of the entire player character is rotating, it's kind of hard to be able to see, and we disappear when we move to the side. So now we're going to address that issue. But we have all of the fundamentals set up and currently working. So let's go ahead and dive in and get it to where the camera is always facing the sprite, or rather the sprite is always facing the camera. So we're going to come back over to our CBP underscore player. We're going to come out to our event graph. I'm going to move these. I'm just going to get rid of these for right now, actually. I'm going to bring up our event tick. So what we want to do is we want to be able to get our sprite to always be looking at our camera. So let's go ahead and get that set up. So I'm going to grab our sprite here. Then I'm going to get its world location. Okay, so then I'm going to grab my camera. And we'll change this later on, but I'm doing this on purpose so that way you can be able to see something. We're going to grab the camera location. Get world location. Then we're going to get find look at rotation. And what this does is that this takes the start and it finds where the direction and where to look at our target. Then I'm going to drag this out a little bit. I'm going to add this here from our sprite. We're going to want to say get world rotation. And then we'll want to, again, I'm just going to make a duplicate for right now. Off the sprites, a set world rotation. And then I can just eliminate that. So, we're going to plug that in. Now, here we're not quite done yet. We're not just going to plug these in here. So, I'm going to split all of these pins. And what we're going to do first is we're just going to take our X and our Y from our sprite rotation and plug that directly in. Then we're going to take our yaw from our look at rotation and plug that in. But this isn't going to quite work yet. Oh, we need our target. Let's go ahead and drag that over. We'll make this look pretty here in a second. So this isn't going to quite work quite how we want it to yet, and I'll show you here. So if I hit play, it's going to look like it's disappeared. And that's because when we are looking at it, it is basing the rotation of what is looking at based off of what the side is here. And taking this and rotating it isn't going to change that. So if I take this and I rotate it and hit save, it's still always going to look to the side. So what we have to do instead is come here and we're going to add -90 to our yaw, and then we'll plug that in. So it's going to look at it and then it's going to rotate it another 90 degrees. So then once we test it, if we're moving everything around, everything looks fine. Now right now if we turn, it looks like when we go to move, everything reorients itself, but it isn't quite working the way it is because we're not really, the sprite isn't updating the animation in order to look correct. Once we move, everything looks fine, but while we're in place, it doesn't quite update. So what we need to do is we need to figure out the direction that the sprite or the forward of the actor is facing and change the sprite whenever we swing the camera around. So what I'm going to do here, I'm going to take this, I'm going to make that aligned. I'm going to take these, I'm going to align these up a little bit. And take these, I'm going to align those, move that in. Just doing some cleanup, make things look a little bit prettier. And then I'm going to take what I have here, bring this in. And I'm going to collapse this down to a function. I'm going to call this function face sprite to camera. Let's fix that spelling. And now we're going to work on getting the sprite direction. And this is a lot more simple than you would expect. So, first thing we're going to do is we're going to get the camera again. We're going to get the world location. We are going to get the actor location. And we're going to subtract these two from each other. And this is going to give us the distance of the camera in relation to the actor. Then from here, we're going to normalize. Now, you don't necessarily need to normalize, but what normalizing does is this takes this distance, and right now we're getting the direction and the distance, and it just gives us just the direction. This will work without the normalize if we just continue on. But this just kind of helps protect us from anything future. We only want the direction. We don't care about the distance between the player and the camera, at least not right now. So we only care about getting the direction. So normalize helps us be able to isolate that. So the next thing we want to get is our actor forward vector. And we'll also get our actor right vector. And then we're going to use a dot product. And what a dot product does is it allows us to compare if two different things are facing in the same direction or not. So we're getting the direction from the actor to the camera. Then we're getting the forward vector of the actor, and we're looking at what that direction is if they share the same. So we want to make sure that our dot product is, our normalize is first. Then we'll get our forward vector and plug that into there. And that gives us a value between 1 and -1. So 1 means that we're looking the same way. -1 means we're looking in the opposite direction. And everything in between is kind of that fuzzy, we're kind of looking off. So then we're going to do the same here. We're going to copy this dot. We're going to put that into the bottom. We're going to plug this in here. And again, this is going to give us a value between 1 and -1, which we'll use to plug in here. So now I'm going to take this, I'm going to promote this to a variable, and I'm just going to call this this is going to be y direction, and promote this to a variable, and this is going to be our x direction. We're going to plug this in. And again, we'll make this look pretty here in just a minute. Then I'm going to come over to my animation blueprint. So now, instead of having our x-axis and our y-axis, we're going to get our x direction. And then we're going to get our y direction. Now with this, we can't necessarily plug the y in right away like we could before. So we need to do something different. We need to multiply this by -1. And this is where I had mentioned earlier, if we set up our AnimSource a bit differently, this would allow us to be able to circumvent this. So right now, forward is associated with up. So when we are at the 0, 1 position, that is looking away from us versus the 0, -1 position. So if we had used this sprite for our 0, -1, then we wouldn't need to multiply things by -1. But the way that Unreal does things, we have to add this -1 in here. But this will be able to fix our problem. Otherwise, we'll get some funky behavior. Okay, so now that we're testing this, we can see here, if we walk down, things are working the way that they were working before. But now if I rotate the camera, you can see that the sprite also updates based on the direction of the arrow. It always looks like our character here is looking in the direction that our front-facing arrow is looking. And that makes things really nice. That gives us this third-person camera, this 360 camera view, with a 2D sprite object. And this allows us to be able to have this kind of really cool 2D character in a 3D world with having complete freedom of our camera. Now, one thing I want to be able to mention is that the way that we set it up here isn't quite going to work if we try and place other characters. And I did that for a reason, but let's go ahead and take a look. So if I grab, let's say this guy here, and I'll turn him around, and then we'll make another version. We'll turn him so that way maybe they're looking at each other. And then I'll grab another guy here, and he'll come, and we'll have him looking at these two maybe from a distance. And then let's just add another guy all the way over here. And we'll have him off looking at, we'll have him looking in this direction. So if I now go to play, you'll see that our character still works the same. But these guys aren't updating the way that they need to update to. And that kind of causes a problem. So here's how we're going to fix that. Earlier, I had it set up to where we were grabbing our camera. And this is our camera local to the current instance of that blueprint. So first thing I'm actually going to do here is I'm going to take this. I'm going to collapse this down to a function. I'm going to call this function get sprite direction. We're going to fix that P. There we go. So that just makes things nice, easy, and readable. So I'm going to come in here first. And instead of going with getting our world location from our local camera, we are going to get our player camera manager, and then we're going to get its location, camera location, and we're going to plug that in there. So then if I copy that and I come over to our get sprite, instead of our camera here, I get our player camera and plug that in, and I hit compile, save, come back here. Now what you'll see when I hit play is that all of them update dynamically. So they're now all reacting based off of the camera position of the player character to be able to give this look that these guys are this faux 3D world. So there's a couple things that we can also do here to kind of make this look a little bit better. So let's go ahead and do that. So the first thing I'm going to do is come over here to this sprite here, and I'm going to take this masked unlit, and I'm going to turn it to a masked lit. He's immediately going to get a little bit darker, but that's going to make things look a little bit nicer. And if I want to, I can turn around and I can also tell this to cast a shadow. And that's going to give us some nice shadows here, but we start to run into the issue that we were running into before a while back, where if we get to a certain angle, the shadow disappears and it looks kind of weird and funky. So let's go ahead and address that and fix that issue. So this is going to be kind of relatively similar to what we have here, but we're going to have to do a little bit of extra legwork. So first thing I'm going to do is I'm actually just going to copy our face sprite to camera. I'm going to make a duplicate of it here. And I'm going to say face shadow to sun. Let's move this here. And then I'm going to come here and under get sprite direction, I'm going to duplicate this as well. And instead of get sprite direction, I'm going to call this get shadow direction. So there's a couple more things we have to do in order to set this up. I'm going to clear some of these out because we don't need all of these. Sprite direction. There we go. Okay, so then next I'm going to duplicate the sprite, and I'm just going to call this shadow sprite. I'm going to take this and I'm going to rotate it 40 degrees. I'm going to make sure that it casts shadows. I'm going to say hidden in game. And then I'm also going to say hidden shadow. So if I save this and play, we're going to see we have, right now we have 2 shadows, but as we turn and walk around, we have the same kind of effect. So let's first make sure that we have our Sprite 0 shadow cast shadows turned off. So what we want to do is we want to be able to do the same thing that we did with this character facing the camera, but with this sprite and have it always facing the sun. So that means all of these little guys here need to be looking at wherever our sun direction is. But one of the things we want to do too is also make sure that the sun is, or that it reacts to the sun dynamically. So we have some setup. First thing I'm going to do here is I'm going to come back, I'm going to get the begin play that we did not have before, or that we got rid of. I'm going to say get all actors class. Then I'm going to get our directional light to get a copy of our 0Q, because it's the only one that we have. And then I'm going to promote it to a variable, and I'm going to call it our sunlight. And that's going to be stored there. Then we're going to come into our face shadow to sun. And this one's going to be a little different. So we're going to come down here, we're going to grab our shadow sprite. We're just going to pop this in here instead. Again, now we are under our face shadow to sunlight function. Now what we need to do is, instead of getting our camera location, we need to get our directional light location. But it's a little different because we cannot get the physical location because of how the directional light works inside of Unreal. So while this currently is at 00220, our light is coming from an area way out over here. You can see the sun that's kind of like right there. So we want it to be facing that direction, but there isn't a real solid way for us to be able to do that. So this is what we're going to do. We're going to get rid of these. So we need to grab our sunlight. We're going to get our actor forward vector. We're going to multiply this over here and tell this right click that pen and change it to a float signal by -1. We're going to duplicate this. And we're going to make this 10,000. And the reason we're doing this separately is so that we can be able to control this differently if we want to turn this into a variable. We're going to grab our world location here. We're going to add these two together, and that's going to be our target. Now we can go ahead and compile and save. Everything else we're going to leave the same that was copied over from our face sprite to camera. And that looks pretty good. So let's come over here. Let's make sure that this is hooked up. And that's still good. Our shadow still at that angle, compile, save. Let's come back down. We can now see all of our guys have this here, but they're going to disappear as soon as we play. If we go ahead and say play, we now have our shadow that is always there. And that helps add a little bit of nice level of realism to it. But now we want the shadow to update its direction too. So how can we make that happen? That's going to be a little bit more difficult because when we're looking to the right here, we want the shadow to reflect that, but when we move around and now it looks like we're looking to the left, the shadow also still needs to stay looking in that same direction. So we need to do something similar to where instead of getting that direction in relation to the camera, we want the direction in relation to the shadow to the sun. So let's get that set up. And we did that here by creating a copy of get shadow direction. And instead of getting the player camera manager, we're just going to come back and grab all of this here. And we're going to drop this in just like that. Now, it still isn't going to fully work because we're setting these directions here. So we actually need to change what these variables are first. So let's go ahead and do that. So we will again promote to a variable. And this one is our forward vector. So we're going to call this our y shadow direction. And we'll promote this. And call this our x shadow direction. Plug that in. And plug that in. Now we're not quite done because we only have one animation component, and this can only connect to one sprite at a time. So we need to add another animation component. So come here and say animation, paperzd animation. And I'm going to call this shadow animation. And its render component reference is going to be our shadow sprite. And if we connect our red here, it'll produce an interesting result. So we'll get something, but it won't be quite what we're looking for. So we can see things look nice, but when we turn down, we turn to the right, we see, okay, that looks fine. But as soon as we rotate around, our shadow is now looking in the opposite direction. When we're looking at it from this angle, it looks correct. Our bill is on the right side. But when we get to the back side of it, everything switches around. So what we have to do in order to solve this is we have to create another animation blueprint. So I'm going to come here to paperzd. I'm going to say paperzd animbp off of our AnimSource red, and I'm going to say abp underscore red shadow. And it's going to look very similar to everything that we have in our red. And in fact, we can just copy everything over for right now. We'll have to do a little bit of cleanup. This will keep things moving by quickly. So if we do that, yep, that's not going to like that. So let's just promote this to a variable. And then we'll have that here set up. And then we'll come over here, and if we just grab all of this and copy it, we can just come here and come to the anim graph. We'll zoom out a little bit. We'll paste it, plug that in. It might still break. We'll see what happens here. Nope, everything seems to work as it's intended. Let's just make sure things here. Yep, it was able to find everything that it needed to find, which is great. So now we are exactly how we are set up in our red BPs. So we need to make a couple of changes here. So let's head out to our anim graph. I'm going to remove these. And I'm going to grab instead our Y shadow direction, or X shadow direction, and our Y shadow direction. All right, so if I plug these up, we're not going to get what we want. And that's okay. So one thing I think I noticed as well is that we did not connect our get shadow direction. So we're not actually getting any values here. Okay, so let's make sure that this is, and then let's make sure we update our thing to our red shadow. That, okay, well, let's see what happens here. All right, so we're looking to the right, we see the right, and when we turn around, our shadow stays the same. So when we look to the right, we can see how our bill matches up. And then if we rotate the camera around, our bill stays in the same direction. So now we have a camera and a shadow that looks exactly the same no matter where we're at. And the same is going to happen with any of these guys. If we turn and walk, their shadow is going to represent the direction that they're looking no matter where we're at in our camera position. So, and the really cool thing about this is now if I want to go ahead and update my directional light positioning, so let's say I want to bring it over this way a bit. Let's make it a little bit more dramatic. And I hit play. That has all been completely updated. And we now have our shadow that looks really good. And then we can cast shadows on each other. And it looks really cool and really neat. One last thing I wanted to be able to touch on this is how this works for a lot of different angles. So right now we've been looking at everything from a third-person camera perspective of using this 2D sprite. But we can even come in here if we want to take a look at our camera. And if we change our projection to, let's say, orthographic. And then let's take our boom arm and let's increase this by, let's say, where is it? Let's go to 1,000. That means it's all the way pushed out there. It creates this really nice and really cool orthographic look and effect. And the reason I push the camera back is you can see how we're kind of clipping into things here because that means the camera is a little too far. So if I left the camera at 500 and I did this, even though it looks like the same, you're going to start to see these guys turning. So you can see how this guy is turning here. That's because in world space, the camera is a lot closer, and these guys are always looking towards the camera. So if we push this back a bit, again, let's do 1,000. Now when we walk by these guys, they don't necessarily turn. We get to the edge of the screen, so that's happening a little bit more there. So let's maybe take this and let's bring the ortho width down to like 1,000. So now we're a little bit closer. It won't look so bad. So we can still see we're getting a little bit of that. So maybe we can push the camera back. Let's push it back by 2,000. Yeah, there we go. Things look a lot nicer this way. If we're down, obviously it's an orthographic camera, so it's always going to, things are going to look the same. But if we're at this kind of isometric look, these guys are doing some weird funky behavior when you get really close. Oh, that's because the camera's getting obscured. The spring arm is, if I get in front of one of these guys, the spring arm is going into effect. So we can even counteract that. Like if we take this back down to, let's say we take this down to, let's do 100, but we push the camera out by -2000. We get the same effect, but now we're not getting that weird behavior. And we can still be able to rotate the camera 360 degrees and still get them to update the direction that they're looking. And it just looks really cool. So it's just a really cool effect. Gives your player complete control. We'll go ahead and push everything back to the way that it was here. And we'll push this back to that. We'll bring our spring arm back to, what was it, 500? Let's do 750. And then now we're back to our view this way. So we have one more thing that I would like to do just to make this a little bit nicer. If we go all the way up, we can go all the way up and we start to see kind of the illusion breaking. Same thing if we look all the way up, we can look straight down and kind of see and lose that 2D effect. So let's kind of put some clamps on our camera here. And that's going to be really simple and easy. I'm just going to build this right in to our CBP player. And we're just going to get our player camera manager. And there's a that we can grab that is going to be our, we're going to set our view pitch minimum. And then we're going to set our view pitch maximum. Let's do 30 by -10. So now we have a limit on how high and how low we can be able to take our camera. Let's actually increase that. Let's bring it down to 0. Let's give us a little bit more view. There we go. So now we can come all the way down to that level. Actually, let's say -35. I'm going to give us 10. There we go. That feels a little bit better. But now we can't hit the top and we can't get too close. So we're always looking at a decent view. We get a little bit of perspective, which is really nice. And other than that, it doesn't break our illusion at all. Thank you so much, guys, for joining us today. I appreciate it. This was a long one. I hope this adds some really cool player agency with the camera in your 2.5D games and just adds that extra little touch to your projects. This has been Classy Crustaceo with Crustaceous Studios, and as always, happy developing.